Hello, welcome everyone. I'm just going to put myself on screen now so I can talk with my hands. I'm Bruce Calder, I'm the VP of Consulting Services here at Claigan. A very busy agenda today. I'm going to talk about this. PFAS is in a very practical sense, but in the first half, I'm going to talk a little bit about the regulations because it's worth explaining the regulations a little bit to explain the answer. And the answer has to be to a question, and you need an output. So talking about the question is and what the output is makes the compliance process make a heck of a lot more sense. If I just kicked right into how you do it, it won't make as much sense if I don't explain why and what. So we're going to talk a little bit about PFAS regulation globally, an update also from this week from Maine. I'm also going to talk about PFAS uses, especially in physical products, but overall, so you have an idea of the broad spectrum of uses, in particular in physical products. The overlap or lack thereof between reportable, intentionally added PFASs, and restricted, generally unintentional PFASs, and why there's very little overlap. I'm going to take an example company with consumer and professional products and also some chemicals and so on and so forth, and how to become compliant. And to be compliant, we look at this is what you have, this is what your output has to be, how do you get from A to B? And we'll talk about what we do there. And a little bit different, we're going to talk about physical products, articles, and a tiny bit about chemical products, something like reagents and liquid paint, liquids, gases, and powders and such, and how it's a little bit different. Then do Q&A at the end. So if you have any questions, feel free to submit it in the control panel, and I'll try to get to as many as possible. So first about the restriction that thou shalt not have. Restrictions today, other than some very sector-specific requirements around PFOA and longer, the perfluorooctanoic acid, 8, so C8, it's often called C8 in the industry, and longer, PFNA is known in 9, and PFDA is DECA in 10. Long chain perfluoroalkyl carboxylate. So what's restricted is most just in the EU and to a limited extent California, restricting PFOA and the longer versions, these surfactants, usually unintentionally there, could be inside fluoropolymers, or PFAS. And then we're talking about, Canada's going to ban PFOA in physical products sometime, but likely not at the 25 parts per billion in Europe, more at the 1 ppm, which will be much less of an issue for physical products. Vietnam is probably also going to ban PFOA in family at 1 ppm. Singapore is going to ban, but very limited scope. And people also talk about, hey, Maine's banning all PFAS at 2030. Not really. What actually is it's a little bit of brinkmanship. It's basically saying, hey, we're going to ban it all unless A, the feds come up with their own regulation and we'll follow that. B, the states, we agree on an approach and we'll go with that. The law actually states in it, if it's federally preempted, we'll follow them. If the states get together and make an agreement, we'll follow them. And if none of that falls through, we have the ability to exempt critical uses on our own. So any ban is probably going to be sector specific. It might be along sort of California's lines of banning in food contact packaging and banning PFASs in consumer water repellent fabric. The REACH restriction was, well, EU's going to ban it all. It's also going to be sector specific. They're not going to ban PFAS in general. If you go to the Maine, literally type into Google, state of Maine electric cars, European Union electric cars, and see how important it is to their future from a government perspective. You can't have those batteries without PFAS. You need the binder. It's one of the things that makes it very efficient in the lithium-ion battery. You need the PVDS binder in the cathode. Otherwise, if you want to ban PFAS, do you think, hey, they're going to ban all PFASs, no more electric cars? It's not happening. Mostly going to look at sector-specific stuff. So, while the word says we're going to ban it, I know, but the small print says, the feds figure out something different, we'll go with that. And B, we can exempt sectors and so on and so forth. The REACH restriction, the name is ban PFAS, but the consulting document is sector-specific. There is a reporting requirement. It's mandatory. It's Maine, January. So there's also reporting. This is different. The recording deadline for Maine is January this year. Now, there's the ability to, and mostly everybody did, get a extension till the middle of the year, but you only have about 5 months left. Even if you got an extension to the Maine reporting. It's mandatory. And you can see other reporting at the US federally. It depends whether there will be a volume threshold. You might have to have 2,500 pounds of PFAS a year to report, but currently there isn't. But there will be federal level under TSCA. TSCA means no medical devices or food contacting under that reporting, but everybody else. There'll be a lot more state level. You can see Colorado and California have state level PFAS reporting, and Canada will ask the question again at some point under Section 71. This is reporting. It's required for intentionally added PFASs, but it's not a restriction. The restrictions to the PFOA and family. The reporting is the intentionally added, which you'll see later are actually not overlapping whatsoever. They're not the same chemicals. So it's kind of interesting. That's why I'm going to do a bit of chem off the bat and details. Make a lot more sense. So, but the thing is, whenever we do compliance, we always look what the outputs are. You're not doing this for fun. And people say, hey, you should get, do testing, or you should, gather data from suppliers or whatever. No, that's a method to get to an end. And a lot of them are rotten. Data gathering from suppliers is pretty ineffective. We have a test lab. The only reason it works well is nobody checks. So it doesn't actually work, just people don't know it doesn't work. We have yet, it has not occurred yet, where we've seen the full bill of materials information from suppliers and we've tested it and they don't agree. They never agree. No, some parts of it agree, but they never agree. What's in your product and what you're told is in your product never agree at 100%. It's just the way it is. So we always look at the output. What are you trying to accomplish? So reporting, you need to have a description of the product, including a brief description, the tariff code, and intended use. Awesome. What's the purpose of the PFAS in it? Awesome. What PFAS is in there by cast number and by weight? Awesome. So that's the answer we need to know. Which PFAS in the which product or product family? What's the PFAS in it? Where is it used? And how much of it's there? Awesome. Do I really have to know how many different, FKM gaskets? I know we have FKM. We just estimate the weight. If you can't figure out the weight, nobody else is going to either. But the main point is to report FKM. If it's 8 grams and you only reported 5, it's for reporting purposes, it's fine. But the main thing is to get the PFAS reported. If you miss them and they're reasonably available, then that's a problem. And the name and address of the company and the name and contact information of the contact person. By the way, you might see that Maine has a little hyperlink updated there. It got updated, the rules got updated this week. So there is a hyperlink to the updated Maine rules. And you'll see it at this, which I simplified here. You have to report these things, and it'll probably be into the interstate clearinghouse database, but that could change. In the future, and you see the main thing in the main, but it's not required right now, you're gonna have to have a plan for the replacement of the PFAS, what the alternatives are, and the justification for continued use. That's not today. That will be sometime in the future, but it's not today. Today, you're really just looking at these. This is what you need to report. And whether it's here or California or Europe, they're basically all the same thing for reported purposes. So again, we always try to look at the outputs. Restriction, a little bit different. You can't have PFOA or longer in a component above the regulated limit, usually 25 parts per billion. In Europe, if it's 1 ppm like Canada, that's not gonna be a problem. PFOA won't be in physical products. Might be in cosmetics, but won't be in physical products above 1 ppm. 25 parts per billion, yes. Your average PFOA concentration is a couple hundred parts per billion. You just can't have it, but there's no specific declaration of paperwork requirement. There's no technical file, there's no label. You just thou shall not have. And I'll explain how that's handled. So one is reporting. You have to report it at the intentionally added PFAS level. The restrictions are exclusively PFOA. You might say, well, Maine's banning it 20 to 30. Not really. There will be some things that are banned for sure, and it'll be the same as everybody else. It'll be PFAS in food contact packaging. It'll be PFAS in rugs. It might be PFAS in water repellent fabric, which is a dumb thing to ban, but anyways, that's what it's going to be. It's a brinkmanship. They basically have the next passage after says we're going to ban in 2030. Oh yeah, if the feds have a different rule, we follow those. Next line is other states have a different rule, we'll follow that one. If none of those work out, here's how we exempt product sectors from the restriction. So it's a little more complicated. So the main thing right now, this is the restriction and the reporting is on the previous page. That's what you have to focus on. What's going to happen 7 years in the future is anything. There's going to be a lot of things that happen in that time period. Now, first of all, what's a PFAS? We know it's long, complicated, long definitional. Okay, the chemical formula has to have one of the things on the left or one of the things on the right. That's it. It has to have fully fluorinated methylene or fully fluorinated methyl. That's all. And you might go, hey, can I have a list of cast numbers? I'm like, no. You have no idea what you're asking for. It has only 2 structures. See, the reason is you can have a fluorinated substance with 1 carbon fluorine, 2, 3, 4, 5, 6, 7, 8, up to 20. And then that, after a certain length, could be branched. It could be a bunch of other things. And in reality, none of these, most of the PFOA doesn't exist in solid form. In solid form, powder form, it's PFOA hydrogen, hydrate, or it's PFOA sodium, or PFOA potassium, PFOA ammonium, PFOA. When PFOA is in water, it's really PFOA minus. So it has a salt on it in physical form. So PFOA, there are really about 20 chemicals that are PFOA when they become water. Each of them are all PFAS. That's just for the PFOA. Every single length has a different one. And then if we look at fluoroethers, which is what you use to degrease your metals before electroplating, you can put an oxygen anywhere inside that chain, and they're all different chemicals. It's infinitely long. So trying to get a number of cast numbers and then go to your suppliers, say, here's 10,000 cast numbers, do you have it? Don't bother. And you'll see that never comes up in here because it's kind of pointless. More than kind of pointless. So the other key thing is what's a polymer PFAS and what's a non-polymer. PFOA is a non-polymer. The polymers are what you use. When you have a physical product, you're basically using the polymer version. What's restricted are non-polymer versions, and they're not there on purpose, and I'll explain why. Now, overall uses, these are all the uses of PFAS. There's also some other more esoteric ones, the pharma side, but one of the main uses is heat transfer liquids. So we have a very powerful high energy electronics, especially server. You can often use fluoro fluids to transfer the heat more efficiently. It's a very specific application. The fire suppression fluids are probably the most general usage. So your fire extinguisher in your kitchen or the extinguisher system in your building, that's usually C6, so 6 carbons long, PFOA is 8. Firefighting foams based on that, and it's all fluoro. It's all fluoro PFASs. Solvent cleaning and degreasing. So if you have machined parts, or even more commonly electroplated parts, we have a part that's machined and electroplated on top, they do a cleaning and degreasing. Most cleaning and degreasing is with a PFAS family called fluoroethers. It used to be done with CFCs and HCFCs, but those have been banned here, there, and over time. CFCs and HCFCs, which are also PFAS, I don't really have here. They're refrigerants, which are also to a certain extent heat transfer fluids. Where a lot of companies will be impacted by changing regulation PFAS is the machines that do the degreasing of their machine parts are all optimized with very specific, often a 3M material, PFAS. When they switch to an alternative one, the machine won't be as optimized in degreasing, and you're more likely to have quality problems. And it's because the machine is optimized, the degreasing machine is very much optimized to whatever PFAS is used. It says PTFE powder, but it can be any of the fluoropolymer powders. And we'll explain this later. A lot of cases, the fluoropowders is how you make a solid fluoropolymer. It's really a powder that's fused or cured into a solid part. Or if you coat PTFE coat a metal like a Teflon pan, the PTFE is actually coated in powder, and then you cure it and fuse it into a single layer. And that's one of the main uses in physical products. It's originally as a powder that's fused into a solid coating or a solid part. Liquid and stain repellent. Fluoropolymers are by far the best water and stain repellent material. So fabrics, but also other fibers, etc. And I'll show the side chain PFAS polymers, which is a very different family. What's on your Teflon pan and what's on your water repellent coat are not the same. They're both PFASs, but they're not the same. And one of the problems is the replacements for PFASs often are really poor at the job. Silicone can repel water fairly well, but it absorbs oil. So it absorbs stains and stinks, and it's just a bad idea. Fluoropolymers are also much less reactive and a lot safer. Cosmetics. So when so-and-so is saying, hey, I'm getting this PFOA in the water system, and they sit there and blame DuPont or whoever they feel like today, sometimes it will be firefighting foams. Most times it's cosmetics. It's literally mostly women's makeup Ones that have SPF like 15 and higher, they're silky. They have C9 until this year. It only stopped doing about 2022. They have C9 to C15 fluoroalkyl phosphate, which is basically a fluoro polymer type material, but it's really PFOA. It really is just PFOA, and you spread it across your face. By the way, most makeup is plastic or rubber. Almost every makeup you have, if you're using the makeup side, has that methicone. It's silicone rubber. So normally the way you create a certain amount of water repellency in your skin is the makeup really just coating yourself with silicone rubber. In this case, it's really coating yourself with a variant of Teflon. So when you look in the water supply, you know, California blames DuPont or 3M for what's in the water supply. It's not them, it's the cosmetic side. That's where it's coming from. That's the main source of it in the water supply. It's the higher SPF makeups, underlayer, base layers, bronzer, all the good stuff in life. Now, as of 2022, it's not being seen as much. We definitely did a survey, and a lot of chemicalists have switched over in this past year. And then there's in the specialized side, like our lab, there's chemically resistant plastics. It's basically take polyethylene and you bombard it with fluorine and oxygen, and you create a fluorinated polyethylene, which counts. It's a chemically resistant container, but it's actually not your typical way of making it. It's actually taking another plastic and then fluorinating it until you create PFAS. So these are the main families, of which refrigerants are also really in the heat transfer fluids also. So you're looking at electronics or refrigerants, which I should have marked separately, are the heat transfer fluid side. And that's really the main PFAS uses. There's some esoteric ones, but this is really where we're seeing it. In physical products, we're really seeing it as the powder version fused into a coating or a solid part, or we're seeing it as a stain repellent, a water repellent coating. We also definitely see these coatings, these stain or repellent coatings or friction repellent coatings on hookup wire. Hookup wire is probably one of the most common sources of PFAS in a product. We see it on the hookup wire. It's a protective coating on a lot of hookup wires. So in the physical products we're looking at, we often see it. This is one of the ways we see it. We take a powder, PTFE or PVDF, Kynar tubing is the same thing, which is PVDF, is you take a fluoropolymer powder. So the way PFOA is used here, PFOA is used in the manufacturing process to create the powder, not to create PTFE. That's really just polymerized TFE. It's used as surfactant to get the oil and water to mix in the PTFE manufacturing, and its concentration controls the size of the PTFE powder particle, which is very important when you're applying it. So you're putting it in a mold and you're fusing it at 400 degrees C into a solid PTFE part like the bottom left, or you're putting on a powder on a metal and you're bringing it to 400 degrees C and you're fusing it as a coating on top of the metal. And so that's its main application as a physical product or on metals. In the other one in physical products is as a side chain polymer, which is super common. So whether it's on fabric or it's on hookup wire, it's almost always side chain polymers. You know, what the bloody heck is a side chain polymer? What it is, it's usually acrylic polymer. Acrylic polymer is like PMMA, polymethyl methacrylate. Your contact lenses are acrylic polymer. It's like the fabric or the wire, acrylic polymer, and then it has sticking out the side, you know, joining on it as side chain a fluoro, PFAS. And it sticks out like tiny little miniature hair. And that's how the water repellency works. So the way why fluorine carbon is so water repellent is the fluorine carbon molecule has no electrostatic charge. It's got zero charge, which means water, which is extremely polar, the oxygen is extremely negative because it's pulled all the electrons from the hydrogen, and the hydrogens have lost all the electrons. They're super, super positive. So it's very much attracted to other polar substances like glass or metals. When it hits a carbon fluorine, there's no electrostatic charge and it just bounces. And that's its main use type. So it either has to be fused on solid polymer or be stuck as sort of a surface fingers or hair sticking out of acrylic polymer, and that's your waterproof jacket or your PTFE coated wire. It's like this. Now you can fuse it on high temperature. Sometimes you can fuse it, but often it's for lower temperature materials. It's done like this, where you have it's a side chain. It's an acrylic polymer that every so often in the junctures has this PFAS piece sticking out, which can also break off that oxygen bond, the oxygen in the middle of the chain. It can snap, and that releases a PFOA type material. and usually does that before application. So some of the chemistry, when you put it on the fabric, is going to have some floating around PFOA, and that's why if you look at the Prop 65 prosecutions for water repellent jackets, the reason they got PFOA is because they're using side chain ones, and some of them, the bonds would have broken during manufacturing or not been completed, and you had a little bit of PFOA wandering around in there. It's unintentional. They're not adding it on purpose. It's not reportable, but it is restricted. So that's whether it's fabric or wire. That's often you're looking at. These are side chain, and so that's one of the other uses. Don't worry, it's not a test layer. These, by the way, everybody who register will receive a copy of these slides. They're a little technical. The reason I'm explaining this is I can explain the answer later, and it helps a lot of knowing where things are. And people asked this morning, is it on wire and cable? I'm like, all the time. PTFE coatings are pretty common protective coatings on hookup wire. Not every time, but often enough. And the other one's a bit rare in physical products, but we do have some examples of this, is where they've taken polyethylene and bombarded it with fluorine and oxygen. And in so doing, they create a fluorinated polyethylene, which is a PFAS. Unintentionally, because the oxygen evolved, they create some fluorocarboxylates, which is PFOA. That's not supposed to be there. It's not intentional. It's not reportable, but it is restricted. And so that's why one of the reasons why the FDA frowns upon fluorinated polyethylene in food contact, because it ends up a little PFOA wandering around. So, but back to what you really have to do. Okay, that's cool. This is what you have to report. Remember, it's basically what's the description of the product or product family, the tariff code, the intended use, and often if they're the same tariff code, be amazed what you can stuff in together. The purpose of the PFAS you're using, what the PFAS substance are by weight and cast number, and it'll often be weight and cast number and purpose. The contact information, name and address of the company, and name and contact information of the contact person. It's relatively straightforward. Someday in the future, you're going to have to, what's your plan for replacements and alternatives, and you justify the continued use, but not right now. This is sometime in the future. The main law has whole provisions for it, but they don't really have a plan to do it yet. It's in the definition section of their law, but not in the actual notification section yet. Restriction is thou shalt have. You can't have PFOA longer in Europe, and to a limited extent, Prop 65, above 25 parts per billion. There's no label, there's no declaration, there's no registration, reporting of it. It's just thou shalt not have, and it's enforced. You can't have it. You're not allowed to have it. You're not allowed to have products with it, which is quite different than the reporting. Now you say, well, if I can't have it, but I have to report it. This is a Venn diagram of the reportable PFASs and the restricted ones. You notice the overlap. All the restricted PFASs in articles in chemicals like cosmetics is a bit different. All the restricted PFASs are unintentional, so they're not reportable. So the reportable PFASs are not overlapping with the restricted. It's funny, in none of the laws right now are the restricted ones reportable, only the unrestricted ones. So the fluoropolymers are what you're using, that fused powder, that side chain, that fluorinated ethylene. In so doing, the manufacturing process could have or could create PFOA, but it's not there on purpose. It has no function on the product. It's restricted in Europe, but it's not reportable in, say, the US because it's not there intentionally. So there's no overlap between the two for physical products. Chemicals have a little bit of overlap. These are liquids, powders, and gases. Firefighting foam has some intentionally added restricted PFASs. Cosmetics, the C9 to C15 fluoroalkyl phosphate is an intentional addition of PFOA. And there's some specialty chemicals that have intentionally included PFASs. Physical products, no overlap. Chemical products, there are situations where a banned PFAS restricted one is also a reportable one. So there's a little bit different when you get to chemicals like firefighting foam and cosmetics. And again, as I mentioned earlier, firefighting foam and cosmetics looks like where all the PFOA in the water supply is coming from. Unless you're downstream from like an old Chemours 3M plant, not a 2023 one, a 1970s one, then you might be seeing the water supply from the manufacturing plant. But otherwise, this is really where it's coming from. So, I think it's a lawsuit. California is suing DuPont and 3M for stuff in their water supply. They're going after the wrong people. So again, back to reportable PFASs, restricted PFASs don't overlap for physical products. It's kind of an interesting thing. So everybody's like, well, they're banning PFASs. I'm like, I mentioned earlier, kind of. It's a good title, and it's a great brinkmanship stake in the ground saying, in 2030, we're banning PFASs unless the feds figure out a better rule or the states figure out a rule, or we can still, if nobody figures out a rule, we can still exempt necessary uses. Like automobiles and medical devices and a whole bunch of ways you can't do without it. The funny thing is, okay, if you actually go over what the hazard is, fluoropolymers are about the safest thing you can possibly imagine. If there is a potential unintentional contaminant that is dangerous in high concentrations, but not at the level inside PTFE. It's absolutely harmless in there. If you're going to ban that, you might as well ban laundry detergent. So the reason PFOA is dangerous in high concentrations, like downstream from a plant or something like that, or in your makeup, is because it's a surfactant. It's a very simple property. Surfactants make oil and water mix better. And what they affect is, your kidneys, you have a protein surfactant for processing bacteria. It's pretty fundamental, the whole way your kidneys work. If you mess up that, then your kidney function falls apart. Your kidneys are everything. That's Alzheimer's, that's heart, that's everything. It's your poison filter. And you can also eventually end up with kidney cancer, definitely in the rat testing. When you inject them with PFOA, what you see go down, let's say literally the pooper, is not quite, is your kidney function. So in high concentration is a problem, but so is your laundry detergent. Your laundry detergent is surfactant. It does the same thing. When that got discovered quite a few years ago by a very unhappy series of events from a very unhappy hospital roommates, where one hospital roommate was, I don't know, for whatever reason, really ticked with their roommate and took their saline drip and then plugged it into laundry detergent, and pretty well the other person's kidneys failed instantly. And since then, they've done lots of testing, and alcohol oxalate will knock out your kidneys too. At a higher concentration, and it does degrade more in the environment, but the concentration of alcohol oxalate in your laundry detergent is 1,000,000 times higher than any PFOA in the PTFE. So it's kind of funny, but the restricted ones are dangerous and they're regulated. So whatever you or I may think about the particular chemical, it has a lot to do with, if they banned it, they banned it. However, banning PFAS is going to be pretty tough because the risk assessments are pretty clear cut. Unless it's got PFOA in it, which it doesn't need, it's unintentional. There are many ways to make it without it, or you raise up 900 degrees Fahrenheit and then it burns and releases carbon monoxide, and carbon monoxide is not good for you. But that's 900 degrees Fahrenheit. If something's going up to 900 degrees Fahrenheit in your house, you have other issues. But that's for reporting. Now, if you want to find restricted PFASs, their only use in physical products is unintentionally being in reportable ones. So the overlap for reporting and restricted are completely separate. However, the non-reportable, the unintentionally added restricted PFASs are always in the reportable PFASs. So if you find a reportable PFAS, it has a risk of having the restricted PFAS. It's not reportable, but it has that risk. So a lot of times you'll see later why we look at, hey, let's find the reportable ones and then look inside those for the restricted ones, because it's one after the other. Basically, the reportable ones do not include the restricted ones, but if you're worried about the restricted PFASs for Europe, where you look is inside the reportable PFAS. So their overlap is very strong in this case. Where does the restricted PFAS reside? It resides inside reportable PFAS. So PTFE is not restricted, but PFOA can be inside PTFE unintentionally. It's part of the manufacturing process, but that's where you find it. The PFOA is not reportable because it's unintentional, but it is still restricted, even though you didn't mean it for it to be there. Okay, so here you are. Okay, I understand I have to report. I understand I may have restricted PFAS, but I might not understand all the words I've used, Octa, Nona, and Deca, and I have a lot of products. Now what? Because that walk through chemistry lane was fun and all, but I'm not a chemist. And that's where a lot of people are at. I happen to be a chemist. It does not make me more popular at dinner parties, for sure. I'm also a physicist, which does not help my clothing. By the way, this is salmon. My wife picked it out. She's wonderful. So imagine I take an example company. It's really what you signed up for. So how do you do this? Well, imagine, okay, most companies don't have this complete mix, but let's go there. They have consumer product lines, they have professional product lines, and they also sell some reagents and chemicals, whether they're cleaning solutions or lab chemicals or something that goes with their equipment. So it could be they sell, a cleaning, let's say vacuum, some kind of consumer product that has cleaning fluids in it. There's a consumer version, there's a professional, one for businesses, and of course they sell the cleaning fluids. Or this could be, electronic system or a medical product there are a lot of varieties, and some people have more or less of each one of these. And imagine you say the consumer line, 67% of what I'm selling next year, stuff I sell for years, 1/3 is brand new. Professional product lines is very likely 80% of the product types, not by dollar value, by different products. 80% of them I've been selling for years, and 20% are new. And similar enough for chemicals, where my new stuff has a lot of effort and budget to make compliant, but I'm stuck with all this legacy stuff that doesn't really have the same budget to maintain compliance. I want to keep selling it, but it's not like it has its own compliance budget the way the new stuff does. So how do you do this? Oversimplification, you give it to us, we solve it. If you want to know how the sausage is made, that's all going to be the next section, but it's actually really simple. This is really complicated. We take your products, we work with you, but we basically do it for you, and we give you what to report. Here's what you report, and here's your restriction results and the due diligence you need to support. And I'll explain why that's so important a little bit. It takes about 4 to 6 weeks, and we just solve it. And remember, you only have about 5 months left for Maine, even if in an exemption or so. We solve it. Now, I will explain how the sausage is made if you're really interested, but that is oversimplification. We will just take care of it for you. And I explain how we do that in a moment. So what goes into this? You're like, that's great. You just put a big box there. I just came to this webinar. I got a lot of chemistry, and you said, basically, just give it to us and we'll make magic happen. Okay, so keynote though, you notice in everything we do, you have your products, you have the output. What we do is we find the best way to get from A to B. We're focusing on the output. And we're also a little process agnostic, where we pick the best ways to do it. We're not selling a particular software, a particular solution. We do a lot of lab testing. We got into that for the longest time because it was a much better answer for a lot of things. We, in this case, use combined arms. There is a good way to do it. So the phases in that section where we make the sausage, I know, basically said, what kind of webinar is this? They basically products, Claigan, answer, which is true, but it seems like you're a little less informative than it could be. Okay, so first we identify representative products, and that's a key thing. We're not trying to boil the ocean right now. We're trying to get the output, and I'll explain why representative works as I go forward. Then we do a BOM review to a limited extent. We're not doing at what time do we say supplier anywhere in here? We're not. Chance of us talking to suppliers, limited with one exception. There's a clarification on confidential fluoropolymer coatings, which we sometimes will talk to the supplier. We'll do a public search and double check. That seems weird, but it's probably maybe the most important single line in here. Testing of select components. So if we're doing compliance for a new product, we just roll it in with everything else we're doing, and it's great. If we're doing it for legacy, it's very select. We're just going for very specific parts, for very specific reasons, which keeps the cost and timelines really in control. Then we summarize results. The reason we use testing, it's just so much cheaper and way more accurate than data gathering, but just a lot cheaper. So identify representative products. So we work with you to basically say, what are your main product lines? Let's pick a product from each to represent them. And there are situations where you might go deeper, and there are good reasons to go deeper, but most time, especially for reporting, it's what's represented. The purpose is we want to find a reasonable proxy for reporting. We're reporting it based on this, and we're finding a representative unit for restrictions. We want to say you don't have any of these restrictions, and this is what we're basing it on. There's a reason why to do that. By the way, if you ever had a compliance issue and you said, yeah, my supplier said it was fine, I have never, ever, I've been doing this for 17 years, has that worked with a national authority? Never. I don't know where that story comes from. Never. You said, my supplier said it's fine. Never has worked in 17 years. There are things that work really well. We deal with a lot of enforcement. It's strange is most enforcement's behind closed doors, so you don't see it. Prop C5 being a total exception. So the first one is the BOM review. And all we're doing in the BOM review is not that detailed. We are literally going for two things. We're going for the obvious low-hanging fruit. Your BOM says PTFE tape, FKM gasket. Awesome. We have to report the fluoropolymer PFAS type and use. In fact, it says PTFE tape kind of sped up the process a bit. How many PTFE tapes? We don't really have to know. We're going to hypothesize the grams, but it's all approximation anyways. And if we have trouble doing it, there's no way the national authorities are going to do better, or the state authorities. And if he's like, hey, it's 5 grams, turns out to be 8, there's no real penalty for that. The volume of your product has a bigger impact. And then that's we go for low hanging fruit, easy. And then we also go for the likely PFAS containing parts, non-PVC wire and cable. And it's a variety of other material types, fabrics, etc., saying, hey, these are high risk. We want those to test. But there's a simple screening. We have a WD-XRF. It screens fluorine directly. It's fantastic. No fluorine, no PFAS. You don't have the F, you don't have PFAS. It's so easy. But you're not doing the whole product and making life difficult. I'm doing this part, this part, this part. So the purpose is to find low-hanging fruit declarables. Like if it says PTFE tape, why make your life complicated? It's PTFE tape. Like that's a reportable. Use it. If it's, FKM gasket, Viton gasket, awesome. You have Viton gaskets. How many Viton gaskets? There's no real point banging your head on how many Viton gaskets. Are reasonably good approximations. Goes from there. And then also which ones you want to test because if they have risk, saying, hey, we found the low-hanging fruit and these other parts could contain PFAS. Let's just look for fluorine off the bat. No fluorine, no PFAS. Very simple. Then we also do a public search double check. Like, what do you mean? We literally do Google search of you guys and fluoros, some different floral keywords. It's a bit of experience. The reason is your BOM is really good in your core product. It is poor for legacy stuff and accessories. And that's where we find that for a lot of companies, the extra fluoros, where it's like, yeah, you make pool supplies, we have no fluoros. Yes, but you sell PTFE tape. Oh yeah, we do, don't we? Yes, that's PTFE tape. And realistically, is the national authority is have you seen the list of companies that have applied for exemptions for PFAS in Maine? It goes for many, 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 many pages. They're not testing all those products. They might take a product search and fluoros, and that's how they're going to double check. So why don't we do what they're going to do anyways to get the miscellaneous category? And funnily enough, about a quarter of the fluoros we find for a company are found this way, because they have some miscellaneous category use that's not obvious, and we roll those in. We're selling, pumps, we sell PTFE tape, right? Or they're selling, you sell a PTFE protective case for the badges that go with it. Good point. And stuff like that. Oh, here's a replacement Viton gasket. Yeah, but we don't make that. We made that system for 10 years. You still sell the Viton gaskets? Yes. There we go. And so that's what we generally see, and it's what the regulators would see. That's why we do it. Like, why not spend 10, 15, 20 minutes and clear up the miscellaneous category? Things you're going to be busted for are these. By the way, if you ever do Prop 65, it's the exact same thing almost. I've had probably in my last couple of years in 10 instances where I've told the company specifically, this is what you're going to get busted for Prop 65 because of the way I can see it searching the web. And they nod their heads at the time, and 6 months later they get busted, and nobody's done anything about it. Prop 65 is almost exclusively enforced by searches in Google, Amazon, Grainger, etc., for keywords of product types and then testing. They're going after certain things very, very easily. Then we test select components. We can test the full products, and there are times, especially when you do another compliance, that makes a lot of sense, and it is more comprehensive. But realistically, when we're just looking at reporting and restriction, we're saying, hey, we know these parts of fluoros. We're not even going to bother screening them. These ones are potential fluoros. Let's just screen quickly for fluorine under WD-XRF, and then that gives us all the reporting data we need, other than converting it into the actual chemicals. And then those are the parts I mentioned earlier. The restricted materials don't have to be in them, but they can, and the only place they are, the restricted ones, are in the reportable PFASs. So we find the PFASs, whether it's obvious or we pick it up as a fluorine measurement, and those are the parts we check for PFOA and family. And we can't do all of them, but they're not an expectation to do all of them. This gives you what components to change at one level, or justifies you don't have it, or justifies you don't have it except for this situation, which you correct. And that provides that you've done the work. Why is that important? A lot of you haven't been through any enforcements. I've been through a lot. It's fundamentally, there are two sets of metrics. So first, reporting is on instances and uses, not fine details. They're not looking for a PhD thesis. They're looking for like, what types of products, what products have it? What PFAS are they? What is it used for and how much is in there? That's all they care about. Restriction enforcement is based on two metrics. You have a non-compliance, so basically you have imagine something they find for some reason, you have PFOA in a part, a fabric, a gasket, a wire, or something. And the way they penalize you is based on, the magnitude is based on, did you not do the work that was required? So imagine they find, 200 parts per billion PFOA in a wire sheeting. Not an uncommon situation. And they say, well, that's a tiny bit of PFOA, but you didn't do the work. You can't show me you did the work, and your supplier said it's fine. We don't care. That means nothing. You didn't do the work, but your competition did. They spent, $100,000 of effort. We're going to fine you $200,000. We're going to fine you based on the work you did not do. So that's one of the reasons why we very commonly provide a report. It's very critical, the due diligence report, because show you've done the work. If you've done the work and you can show you've done the work, it's like I have supplier details on my computer. That's not showing the work. If you can show them you've done the work, then the penalty is based on the mass of the restricted chemical. So if you have like a ton of lead, because all your circuit boards are leaded, it's based on that 1 ton of lead. You get fined $100,000 or something for that ton of lead. If it's because you have, as I mentioned earlier, 200 parts per billion PFOA in your wires, and that could be 1,000 wires, that's 5 micrograms of PFOA. And so if you base it on the lead metric, it's about 25 euro cents. It's literally pocket change. So at that point in time, they're not going to find it. They basically say, let's just don't ship it in, fix it. And then we get to say we've completed enforcement and you've done the work. So as long as you've done the work, PFOA is really neat that in your physical products, its mass is so tiny that any non-compliance, as long as you've done the work, there's no real penalty because there's not enough of it. It can't cause physical harm. There's just not enough of it. If they say, hey, you can obviously, poison babies with this because you have, many tons of it, different story. I mean, you're sitting there as a 1970s PTFE plant, you're pouring it into the water supply, quite different. You're talking big time. You're talking, micrograms in your waterproof fabric. It's not anything as long as you've shown you've done the work. It's like we've tested it. All these example products, we didn't have it, or we just had it in these fibers, replaced the fibers. You happen to find it in a hang tag in one. Overall of our products, that is 0.7 micrograms, which is literally half the weight of a fairy's fart. Like, it's not a lot. It's official measurement, probably Narnia. Anywho, so again, back to the fundamentals. We always look at the outputs. So we do the testing part to provide the fundamental data for reporting and also provide the due diligence and restriction information for the restrictions, like for the European Union. We're not trying, we could do, this will give you better results than pretty well anything else you can do. You could do more, and there's sometimes good valid reasons to do more, especially in new designs. You could do more, but you end up spending 10 or 20 times more to get 5% more advantage, which is not what they're looking for anyways. You really want to have accurate reporting and get your instances down in a justifiable way and justify how you got to that point. It also helps you point at, third party did it for us. Okay, so you definitely did the work. And then here's the due diligence for the PFOA side. Yes, you did actually find it in these parts. You've since replaced it, and this shows you've done the work. So that's fundamental. We're not looking for perfection. We're looking at a compliance situation where you can freely and clearly sell your products and meet your requirements. Then so after all that, we summarize it. So for the reporting ones, we put it all together with the descriptions and uses and weights and chemical info. Here's your Excel sheet, just each field they ask for. This is what you punch into that field. It's like, all right, much easier. And then for the PFOA, here's the due diligence report, test report to show you've done the work. Yes, you did find it in this, and then we'll have a memo that you've replaced it and you've addressed the situation. You've done the work, and that's what happens. Now, new designs would be a little more thorough, but we'd also match it in parallel. So something new, there's a higher expectation in legacy products. Brand new product, you normally do more. This is new designs. You combine it with doing all the other global requirements. Most companies, especially in the professional medical side, just send us the product. We take care of everything. If you're only selling in one jurisdiction, sure. But realistically, if it's like globally, it's a lot easier to do everything at once. A lot of people try to do a lot of supplier data gathering. A lot of companies are very fortunate, the national authorities, and while they're enforcing a heck of a lot more, I just had 2-3 enforcement calls today for restricted materials. It is ramping up, but they have been kind of slack for a while. It will also change when ROHS moves from the EU Commission to ECHA. That will change a lot too. So when you do new designs, you amalgamate it. Normally, we just take care with everything else. It's very thorough. Chemical products is a bit different. It's really just looking through the SDS for fluoro. Unless you have a huge amount of SDSs, it's not that hard. It is technically difficult, but it's not very time consuming. If you have a huge number of SDS and chemicals, you often have your chemicals in a library. You go through the library version. Usually in the chemical product, the fluoros are obvious. However, they sometimes confidential cast numbers, and that's one of the times you go back to the supplier saying, hey, I got to report this confidential fluoropolymer or fluoroether. What am I reporting? And that will happen. So again, PFAS compliance is pretty well, you have products, we can fix it in 4 to 6 weeks. Remember, you only have about 5 months left now, and restrictions are already in play. We can solve it, give you what you need for reporting, and give you what you need for restriction. That's one of the big takeaways. We can just solve it in a very efficient way. This is all focused on giving you the answer. By the way, before I get into Q&A, which will be in a moment, the REACH SVHC list was updated yesterday. It's probably the most impactful to electronics since the lead edition. There are 4 new SVHCs, 2 of which they can all be in electronics, 2 of which are pretty darn common. BTPH, brominated basically DHP, and melamine, pretty common in electronics. Basically every skip file for every electronic product pretty well has to be updated this year. We probably do a webinar on it in the 1st, maybe the 8th. And I'll talk about a lot of it, but it's probably the most impactful REACH SVHC update. By the way, if you're wondering, hey, he's making predictions about reporting, how smart is this guy? Well, I like to say pretty smart, but my family has different opinions. Or they still want to hear from me. How accurate into predictions for the PFAS dates. In those of us working us in a lot of companies, we give quarterly and monthly updates. We sit down every quarter, every month, and explain what's changing. Months ago, we identified that it's going to be these 9. They're all going to pass. Melamine had some question, but there's a reason why there's a question for it, but we believe it's going to pass. And we said the SVHCs will be published Jan 17, 2023. And we were right to the day. So yeah, sure, that might be a bit lucky this time, but we're pretty good at this by now. I've been doing this for 17 years. We're pretty good about what's going to happen in the future because we understand what is going on. There's going to be a lot going on, by the way. If you like what we've done today, or appreciated the technical part, if you don't do quarterly updates or monthly updates with us, I really suggest it. We should basically sit down every quarter, every month, and go through what's changing in the space and explain it. And you ask questions. It gets to be very interactive. It's very, very helpful. One of the most fundamental rules of restricted materials compliance are the things you're most likely to be non-compliant for are the things you didn't know about. It's really fundamental. So again, when in doubt for PFAS, come to us. We can just handle it and give you the answer. I know it feels like cheating, but if you're not cheating, you're not trying in this industry. You're really industry. So there's no point banging your head against the wall or well, I really have to justify this big expensive software I've got. Well, just do it. That's not our function. The idea is not to create some reoccurring subscription service with you. The idea is why don't we answer the question so you can keep going? I think a lot of MBA guys might be rolling around right now going, that's not how you run a business, but this is the way we've always run. Where it's you have a problem, we will do our darn best to fix it. And that's the plan. We treat a lot of your challenges of compliance as a challenge, as something to help you with, and not as an ongoing revenue source. I mean, yes, we have to definitely make money continuing. We've done very well. We didn't expect to get as big as we did. We never meant to be that large. We meant to be the best. And I guess that mentality made us a lot bigger than we originally planned. But it's great. We have a lot of good people. I'm very happy. So again, back to the Q&A, not talking about ourselves. If you have any questions, feel free to submit it in the control panel, which a lot of people did. And I'll try to get to as many as possible. If I buy parts, articles in the EU that contain a PFAS, what should I be aware of? It depends. So if you buy something in Europe and you integrate it into your product and you sell that product in Europe, you have to know about, it has to be compliant with, the PFOA restrictions. Like it has to be compliant with ROHS or similar. If you integrate it in your product and you sell it into the US, you just have to do the reporting requirements. So the component is the component supplier's problem unless you put it in your product and sell it in Europe. In Europe, you're less likely, theoretically, to have PFOA and European parts, but you're still quite possible. And from the US reporting requirements, there's no restriction on PFAS in Europe, and even the one in the future plan is going to be very sector specific. There's no, the European ones can have lots of PFAS also. By the way, the PFAS industry is growing every year, quite a lot. It's growing by about 10% a year. It's extremely useful material type. It's very fundamental. Even through all of this, the business for PFAS is growing. 3M, which is exiting the business because of historical lawsuits, not current ones, it's quite a profitable business for them, if it wasn't for the historical 1970s and 1980s factories. There are restrictions in the books in California and Colorado set to be implemented 2025 and 2027. They're both sector specific. The California one is specifically around consumer medium water repellency fabric. Professional water repellency fabric has a later date, if at all. So they're all sector specific. Any PFAS restriction that's hard written today is sector specific. Now, would these essentially not be applicable to articles like tents and outerwear? So though there are sector specific side, like waterproof clothing, which has, depending on the wetness level, it's very, again, sector specific, they will have PFAS restrictions. It may be a bit foolish, because you can make those coatings without the PFOA families. So what happened is a lot of the outdoor fabrics with floral coatings are found to have PFOA. They can be made without it quite well. The replacements, the problem with them is they can be quite water repellent, but they're not normally nearly as stain repellent, and they can stink and discolor and all the bad things in life. So there are sector specific restrictions coming, but they're almost around PFASs in food contact packaging or fabric or clothing. For very specific, if you're very interested in your specific application, just reach out to us, because a lot of very specific say, I make this thing, I make a tent. Does the California restriction really apply? Well, it depends. Does it have to handle heavy wetting? Yes, then the initial one does not, etc. Should I look into non-polymer PFAS, or do I need anything to get the polymer one? So the polymer ones you need to know the polymer ones to do the US reporting, and B, your restricted ones are inside, or the only place they exist is inside the polymer. So you use the polymer situation to find the restricted ones. The polymer ones are what's reportable. PFOA is not reportable generally for physical products because it's not intentionally there. You need the polymer information, which is your use, to report in the US and to know which parts are vulnerable to PFOA. That's why you need it. So PTFE is not banned in Europe at all. However, PTFE is at risk of having PFOA. So if in the US, PTFE will be reportable in Maine, and it could have PFOA, but that's only regulated right now in California. What about PFBS, PFCAs, PFDA, PFHX? So I could do my Latin, but basically the PFOA family has, depending on the length, the O changes. O is octa, N is nona, O is 8, octa, N is 9, nona, D is deca, 10. But I can go the other way, hex, which is C6, and they're commonly used, is short chain and generally not regulated, even though you're looking at it. You can get smaller. There's one exception. I'm not sure I actually even have it in the PFAS uses. It's a good point. I should add that one. PFBS is a flame retardant in polycarbonate. It is PFOA before. It's beautiful. And it's actually got a strange use that I don't actually have listed in the uses as a flame retardant in polycarbonate. It's also REACH SPHC, actually. It's a higher concentration intentional use. It's not restricted right now. But it is actually REACH SPHC. There's a really weird one, PFBS, which is extremely rare. We've seen it. We test tens of thousands of parts a year, if not 100,000 parts a year. We've seen PFBS at low concentrations once, maybe twice, maybe once this year. It's really rare, but it could be a flame retardant polycarbonate. It is another use. As I said originally, when I go over the main uses, there's a few esoteric uses. But what's restricted right now in Europe are all the PFCAs, fluorocarboxylic acids, but PFOA 8 and longer, some long chain versions. Can you walk through a PTFE part? Does it contain PFAS? PTFE is a PFAS. It's a perfluoro polymer. It's a PTFS, and you have to report. It's intentionally there. It's PTFE. You have to report it, but it's not a restricted one. That's PFOA and longer. It's a very specific non-polymer one. So the PTFE is the material. It's what's reportable. It could have PFOA in it, which is not reportable, but it is restricted. It doesn't have to. You can make that PTFE just fine without PFOA. It's a manufacturing aid to create the powder originally in the PTFE part. So PTFE is a PFAS. It's a polymer. It's reportable, but it's not restricted outside some pretty specific applications around food contact and fabric. It may contain PFOA, and it's a risk of containing PFOA, but it doesn't have to. It's not necessary. It's just a material that can be used as surfactant to control the powder size of the PTFE, which is important for processing before it's cured into the physical material. When you determine there's a fluoropolymer component article, what is the next step? Determine it's compliant for the LC-PFACs. That is awesome. So if we know we have a fluoropolymer, we just test by LC-MS-MS for the PFOA family. So if we're down like, hey, this is a fluoropolymer, the only thing that gets down to 25 parts per billion, which is the European limit, is the LC, liquid chromatography mass spec. It's a tandem mass spec. That's how we test for that. But we only guess, again, we only test the specific material. We can easily detect materials that are the exact same, so we only have to do one of them. And they're very refined on what we test for PFOA. It has to be basically a fluoropolymer or fluoropolymer coating, and then we can test by LC-MS-MS down to 25 parts per billion. Will this be shared with the attendants? Yes, everybody who registered will receive a copy of these slides. There also will be recording. You can even slow it down so it makes more sense. Sometimes I babble a little bit too. Sorry about that. Sometimes I may be having fun or stream of consciousness or try not to be too dry. You can slow it down so it makes more sense. So it should be recording online probably by the end of the week. Does Asia have any PFAS restrictions or reporting requirements? Sorta. So there's a big difference in articles and chemicals. PFOA, every country has signed up to ban PFOA and longer. Some are faster than others. Singapore bans PFOA, but a very restricted chemical group, mostly chemical side. China's implementing right now, I think it's just announced that they're banning in 2024 PFOA and longer in imported chemicals, not articles. Japan is regulated in chemicals, but we're dealing really PFOA as PFOA in a chemical. So Asia is generally not heavily regulated. Vietnam is putting a PFOA ban, including articles, but it's likely 1 part per million, which is pretty irrelevant for the contamination levels in articles. By the way, if anybody sign up for quarterly updates or monthly updates, we go over that in intimate detail. I'm doing this off the top of my head, but we actually do. We're doing now, except it's much more interactive. It's not you typing into a question. It's you online with us asking questions about your products. And we're only doing it with you about your products. You can invite any stakeholders you have. It would be extremely expensive because the amount of detail, except we do, I don't know, we have about 80 companies we do the work for regularly. So you get the benefit of what everybody else gets benefit. So the amount of density and information is you get incredible for value for what you're doing. So definitely reach out if you're really interested in this really deep dive regulatory stuff. Definitely quarterly updates where we sit down with a web meeting, not a webinar, web meeting with you. We explain everything, not just this, but the new REACH SVHCs and the ROHS change, and the ROHS change to the regulation, and how the ROHS exemptions are working out, and the next set of REACH SVHCs, and the Prop 65 enforcements, and the antimony trioxide new safe harbor limit for Prop 65, and why it's such a big deal for electronics, and how you handle it. All those kind of things we handle in the quarterly reports. We talk about your product, so definitely recommend. I do other types of reporting, but I can share with some work partners that think do something reporting on this. Perfect. Happy to help. By the way, anybody have any questions afterwards, feel free to reach out. I'm running out of time at the moment. I managed to double book myself a little bit. What typical industries use solid polymer parts? Not Teflon coated PFAS. Medical for sure. Laboratory equipment all over the place. We take a typical piece of laboratory equipment. It's full of fluoropolymers. Anything that really transfers chemical fluids, we'll use Kynar, which is PVDF. Tons of things that transfer fluids have Viton, FKM, very commonly as a gasket material, super common. Anything that needs chemical resistance, for sure, is full of fluoros because that's the main chemical resistant material. It can handle oils and waters, which is not common. Silicone can't do that. Polyurethane can't do that. So we see anything that has to really deal with any chemical resistance has fluoros everywhere. But wire and cable has a coating. But solid parts, gaskets, tubes, it's generally in a chemical resistant situation, but we see them all the time in that situation. Medical devices have it all over the place. They also need the lack of friction of the solid PTFE or FKM or PVDF. It's very advantageous. The main 2030 PFAS ban is all consumer products. No, the main ban is all products. It just doesn't mean a lot. It's a stake in the ground saying, hey, all PFAS are banned in 2030. Unless the federal government creates a law, then that's the law. Or the other states create one, then there'll be that one. Or neither one of those happen. Well, just people can apply for what use types really justify or needed. So it's an inverted one. It's basically saying it's all banned under this, and if nobody else gets around to making a law, we will. But it's really staking the ground for 2030. It's basically a manana one saying, you know what, guys, we have a deadline. You're now going to have to actually do something. And if the feds create one, great, we follow the feds one. The other states create one, we'll follow them. And if you go through the main law, it's perfectly structured, banned in 2030, except there's a federal preemption, or if the states do it, or there is how you would allow or exempt specific applications, like say medical devices or so on and so forth, electric car batteries, and a lot of uses. One of the reasons why they're getting the reporting, they want to know the uses first, then they can tackle what's needed, what's not. Do fluorinated saturated phenols count as PFASs? Technically not, it's CH2 or CH3. Great question. There's a number of fluorinated saturated phenols that are definitely not. They're mostly pharmaceuticals. Others could be. It depends on how the carbon fluorine structure is off the side. If you have a specific molecule question, just send it to me and I can tell you. It's really simple in a lot of ways. People are just, expected. Does it have the structure on the left or the structure on the right? If it has either one of those, it's a PFAS. It's kind of that structure. So whatever the rest of the molecules, doesn't really matter. If it has left or right, it is. If we strictly make articles that utilize polymer types, would the fact that they will be incidental presence of restricted forms make these products restricted? Yes. So if you use PTFE and it has PFOA, it's restricted in Europe, even though you didn't mean to have it. The restriction doesn't care if it's intentional or unintentional. The reporting cares if it's intentional. So again, thanks everybody. I kind of ran out of time. Still lots of questions. Great questions, by the way. Feel free to reach out if you have more questions. And again, we can just solve it. You only have about 5 months left, and the restrictions are already in play. It's in Europe. Just reach out. We'll take care of it. There are good ways to do it, especially when you have a lot of products or it's complicated. We just solve it, and that's the main plan. We'll have another webinar probably in a couple weeks. We'll announce it soon on the brand new SVHCs. Pretty well every skip file ever made of electronics is going to have to be updated if you're still selling that product. Thanks much, everyone. Sorry I didn't get everybody's questions. I ran a bit over time though. Thanks again. I look forward to hosting everyone again really soon.